Welcome back to lesson 67. We're going to make predictions using theoretical and experimental probability. So watch for a few things. Look to see how I express probability of an event. Again, as a fraction, we've been doing this for a while. How I convert the fractions to percents, and I make predictions using proportions. So back to those RP skills that we did so many units ago, and I make comparisons using the data. Here's our first problem. Alicia rolled a die 100 times. Predict the outcomes of rolling a number greater than 4 if she rolled the dice 1,000 times. Alicia created a table recording her data, what actually happened. Okay, so here's the first part. We're using experimental probability here. If we just wanted a theoretical probability, we would just do 2/6 and we would just use that to figure out the actual probability. Now, here we're using her trials, so this is experimental. Here's what we know then. We know that we're looking for the probability when the number is greater than 4. Look how I'm representing that. And we know that happened 32 times out of 100. So in this case, P of numbers greater than 4 was 0.3200, or 32%. We want to predict after, it's a little typo here, after 1,000 rolls, how many times will she get a number greater than 4? So something to note, the probability will still be the same. It's just we're going to use the probability to make a prediction for a number out of 1,000 rolls. My plan is really short. We're going to find that probability, and then we're going to use math to predict out of 1,000. Hit pause and jot this down into your notes. We're calculating the probability when n is greater than 4. And this is experimental, meaning we're using these trials. We're looking at these two numbers here that added up to 32. And we knew that there were 100 trials in this experiment. So 32 out of 100, or P is equal to 32 hundredths, 32%. So we want to know, what would this be after 1,000 trials? If we know the probability is 32%, how many times will we get a number greater than 4 using this data? So we can do two things. I actually put one into our plan, but I also had an idea that we can add on to it. So I'm going to use our probability in our ratio table. And I'm going to put 32 out of 100, and I want n over 1,000. In this case, I'm not going to cross multiply because I can see these are friendly enough numbers that I just want a magnitude of 10. I just want 10 times bigger. So this would just be times 10 times 10. So in this case, n is equal to 320. That is my prediction. If you want to cross multiply, you can. You get 100n is equal to 32,000, and then just divide by 100. You're going to get the exact same thing. And then it just hit me. We don't only have to use ratio tables. We could also do 32%, or 0.32 of 1,000. And that would have also given us 320. So we have two different ways that we can figure this out. Let's put this into our answer now. What actually happened? Predict the total outcomes of rolling greater than 4 1,000 times. We predict Alicia will roll a number greater than 4 320 times out of 1,000 rolls. P of n greater than 4 is equal to 32%. This is based on experimental data. And I'm I'm saying that just so we know this is experimental probability, because this is what actually happens. Now, to really find out what would happen, we'd actually have to roll this 1,000 times, which you're not going to do. But I do want us to recognize the difference between this probability versus the theoretical probability, which would be a number greater than 4. Well, that would be 2 out of 6, or 1/3, which is 33%. So it's actually very, very close. It's only off by 1%, which is tremendous in this experiment. So hit pause so you can jot this down into your notes. We're going to switch things up for the second problem. Usually it's me doing some modeling, but we're going to do something different. Joel and Ellie flip a coin 20 times. What is the probability of flipping a coin and getting tails? Well, we know when it comes to theoretical probability, the probability of getting tails is 1/2. So if we want to find out of 20, we know that it would happen half the time, or 10 times out of 20. That is our theoretical probability. But experimental probability is different. It's what actually happens when you try it out. So go and get a coin, and I would like you to actually try this yourselves and try it with another person to get more data. Flip a coin 20 times and see if you get exactly 10 rolls out of 20 for tails, or if you get a different number, and ask someone else to do the same thing. And when you're done, and you can repeat this experiment as many times as you'd like and record and capture your data, stop and think, is theoretical probability less valuable than experimental probability? Especially if your data isn't matching, what are your thoughts on that? Does that make probability less valuable than being experimental and trying things out? That's it for today's lesson, Math Marvels. I will see you in the next one. Be well.